This is how to derive the law of cosines. I'll never use this formula or this idea because I don't work in the field of physics or engineering. I just wanted to do this to solve a complicated puzzle, and this is a very complicated puzzle. There are a lot of pieces here, but I'm going to go through it and try to make it look easy. Just so nobody thinks I'm super smart, it probably took me about a week to solve this the first time. I'd work on it a few minutes a day, several times a day. And that was maybe a couple of years ago. And I made a video on it at that time, but I wasn't sure if I could do it again, and that bothered me. Because they say that you're really not a champion until you can defend your title. And that's because you might have just gotten lucky, or your opponent might have had a bad day or was sick or injured. So I wanted to prove to myself that I wasn't just lucky and that I could solve this again. So to solve it here a second time, a couple of years later, probably took me about an hour overall. I'd work on it a few minutes at a time throughout the day. So this is what it is. You got your triangle with corners labeled capital A, capital B, capital C. The line segments across from the corner are given the same letter except in lowercase. So line segment lowercase a is across from capital A. Line segment lowercase c is across from angle C, and so on. So you end up with little c right here. I drew a line over the little c to let you know it's not big C. So we have little c squared equals a squared plus b squared minus 2ab cos c. You can try to solve this if you want, and you can pause it, or I will give a hint and show how to do it in 3, 2, 1. A couple of hints are, you see a squared, b squared, and c squared. That means we're dealing with Pythagorean theorem, most likely. And when you see this cos c right here, that means we're dealing with trig. So Pythagorean theorem and trig both mean we need a right angle, of which this triangle has none. So there's a lot of pieces to this puzzle, and I'm going to introduce 3 new pieces. And here they are: H for height, and then D and E, or delta and echo. So the line segment B, as in Bravo, will be divided up into smaller segments of delta and echo. So this gives us 3 new pieces that we'll have to use, but then we'll have to get rid of them later on. And I'll show how to do that. When I shot this video last time, I found out that D as in Delta sounded identical to B as in Bravo. So I'll have to make sure that I enunciate these letters more clearly in this video. Okay, so this could actually be another hint right here with this triangle. If you want to try to solve that, you can pause it, or else you can keep watching. And I'll show what I did in 3, 2, 1. Okay, these letters right here of A and B, D, E, A, B, C, D, E, these are separate than the triangle. This is just going to be a generic statement right here. So if you have these equations here of A plus B equals C, or I could say alpha plus Bravo equals Charlie, and then delta plus echo will equal Charlie. Notice both of these right here will equal C as in Charlie. That means I set this equation equal to this equation, then the Charlies disappear. I get A plus B, alpha plus Bravo equals delta plus echo. Notice I could also rearrange this equation as alpha plus Bravo equals Charlie, and that equals delta plus echo. The C can simply disappear. You can drop it, and you end up with this equation right here of alpha plus Bravo equals delta plus echo. It's weird using the phonetic pronunciations for these letters. I've never done that before in any of my videos, but like I said, B as in Bravo sounds identical to D as in Delta when I shoot these videos. And that is why people invented the phonetic alphabet, so I might as well use it. Okay, so at any rate, remember this right here: when you set 2 things equal to each other, in this case they equal C, so the C will disappear. So what happens here is, I use Pythagorean theorem to solve for the left side, Pythagorean theorem to solve for the right side, set both of them equal to H. When the left side equals H, the right side equals H, I put them together, the H disappears. And I'm also going to show how to make the D and E disappear. We have to use it at first, but I'll show how to make them disappear. This puzzle here of deriving this equation doesn't just teach us how to solve complicated puzzles that require a lot of steps and have a lot of dead ends, but it also shows us that when something's really complicated, we have to organize it. And the more organized you are, then the more sense everything will make. When I organize the left side of this triangle first, I use Pythagorean theorem of instead of a squared plus b squared equals c squared, I can say delta squared plus hotel squared equals Charlie squared right there. Then we can isolate our h's right here. H squared equals Charlie squared minus delta squared. But the problem is we don't want the d as in delta. We have to arrange all of our variables so that we only have line segment Charlie as in lowercase c, line segment alpha, line segment bravo, and we want angle Charlie right there, which is uppercase C. So anything that has H as in hotel, D as in delta, E as in echo, we don't want any of that. We also don't want the angles of alpha or bravo, which is uppercase A and uppercase B. So every time we get this H, hotel, delta, or echo, we need to turn that into something else. This is how you do it. So hotel squared equals Charlie squared minus delta squared. Your delta right there becomes delta plus echo equals bravo. Delta plus echo equals line segment bravo, because I cut bravo in half and made it delta and echo. So since we want delta right there, let's isolate delta from this equation. Delta equals bravo minus echo right there. So now we can plug bravo minus echo into delta. Okay, so that got rid of our delta, but that also created an echo. So let's take echo right there and let's turn that into alpha cos Charlie. We take the angle of Charlie right here. So cosine Charlie equals echo over alpha. Cos Charlie equals echo over alpha. Bring up your A, you get A cos Charlie equals echo. So now wherever we have the E as in echo, we can plug in A cos C. We end up with our full formal equation right here of hotel squared equals Charlie squared minus delta squared. Delta squared becomes B minus A cos C quantity squared. Because remember, this whole thing right here has to go in for delta, so we have to square the whole thing. Anyways, we end up with hotel squared equals Charlie squared minus the quantity B minus alpha cos Charlie quantity squared. Just go through the algebra and it makes sense. Next up, what I'm going to do, I'm going to take this bravo minus alpha cos Charlie, the squared, and sort this out right here and go ahead and FOIL that out. Go through your basic algebra right here to FOIL that out. And then the final equation will actually be hotel squared equals Charlie squared minus bravo squared plus 2 alpha bravo cos Charlie minus the quantity of alpha cos Charlie quantity squared. So a quick question is, do we square this negative sign right here, or do we just square the alpha cos Charlie? We're actually subtracting all this, so we just square the alpha cos Charlie. Okay, so this is the left side of the triangle, which is, get my paper right here. Right here, we did the whole left. Now we're going to do the same thing to the right. The right is actually easier. Bring this down right here. We got echo squared plus hotel squared equals alpha squared. Right there. Go ahead and isolate our hotel squared right there. Turn echo into alpha cos Charlie, because cos Charlie equals echo over alpha. Our full final equation right here is hotel squared equals alpha squared minus the quantity alpha cos Charlie quantity squared. All right, what I'm going to do on the next page here is I'm going to combine the left and the right side of the triangle. Since the left side, this big mess equals hotel squared, and on the right side, this big mess equals hotel squared. When I set these two equations equal to each other, the hotel squared disappears like I showed at the beginning of the video, and this is what it looks like. Get this out of the way there. Set them equal to each other. Sometimes when you get big, long equations, it helps to really embolden or make your signs pretty bold, like the equal sign. Let's see here. We end up with a negative A cos Charlie squared on the left and on the right, so they cancel. Just go through the algebra. Isolate lowercase charlie right here. So lowercase charlie squared will equal alpha squared right there. And then when you move everything from the left side of the equal to the right side, just change the sign. So negative b squared becomes positive b squared, and so on. And you get your equation. And that is the law of cosines. You could say this is how to derive the equation, or you could say this is how to prove the equation. Because in order to get to this final form right here, we had to go through a series of smaller proofs, with each proof leading to another proof, until eventually we got to this form of the equation right here.